we have the fiber conference in Dornbirn. There is also especially webinar build the future scenario of all materials, including structural material, energy use in food. So this is really missing. So the energy needs of our university, our national center already have a systematic approach of it's still missing. So if somebody wants to join us on a project, I'm open for it. Carbon capture usage. We have done this for this stock. We are producing of the stocks, taking carbon dioxide from the air, and then it can be either done by in a traditional chemical process, but this is actually what nature does, taking CO2, making materials. Recycling. So first of all, as I said, the longer and the less you use, the better. And this has by far the largest impact. Then of course, renew, repair. So also there will be a future of craftsmen repairing and business model repairing consumer goods. Then recycle. And then of course, not everything can be recycled. I will go to that later. It has to be always a combination. There is no single way of use in recycling. Don't believe this. And therefore, we set up 5 years ago the recycling atelier for mechanical recycling, as Georg Schlausberg has said. We're also planning pretty soon one in chemical recycling because still a lot of challenges have to be faced. And I can tell you how it works. It is all about collaboration. We have 25 tech partners because we only, and I'm still guy, I only can textiles. So, but if you want to do recycling, you have to include many technologies. And therefore, 25 tech partners are joining together. Our customer come to this place, and then we develop solutions for reuse, upcycling, recycling. This has been proven. There's a lot of course, topics for innovation. Don't be afraid. I don't name every of them. The bottom line is all these challenges for recycling can only be done by cooperation. And please come and cooperate among you, with us, humans. And I want to say, we talk always about textile to textile recycling. Go into my literature, read it, think it. There is no 100% recycling fibers to fibers. Never, ever, never, ever. This is the same illusion like a perpetuum mobile. When you recycle a fiber, every textile guy knows it. The fiber gets shorter. If you recycle a polymer, the polymer gets shorter. And so it's a mare that is 100% recycled. And you always have to think you shall use as much as possible in a circular way. That's for sure, but it's not 100% on the high level. So this is an estimate by me. And maybe we meet again in 10 years and then you can say I'm wrong or not, but make an expert guess. And even you can calculate. I can show you in the coffee break. It's very easy. If you have 10 processes, you have 10% loss in every step. What is at the end coming out? 30%. So, but if you don't understand so far, I can make this calculation also on a piece of paper in the coffee break. So 30% fibers, then you have still material. I will give you some examples. There are other uses for shorter fiber, paper for example. Then of course there's a certain portion which can be used as energy. As long as the material coming from renewable sources, using renewable material for making energy, it's not a worth thing. And then of course there's some waste. I will show you some examples for that. There are already examples. So my later colleague will go into ingrain. Here we take waste from other industries, also an option. For food production, we then take it into high-value material and as well into food stock. And this is recycling the feedstock for the textile industry from the recycling of other industries. I don't want to go in detail because Baga Backman will go on later. So, but the topic is taking the waste and making high-value product, for example, for the food sector, but also for others. There is coupling, I mentioned already, paper and non-wovens. My belief, I like this quote, please remind, paper and nonwovens are the platform material of bioeconomy, because nature provides fibers, polo shirts and the short fibers into paper. And it's working. Then we take this opportunity and all the potential to merge and join efforts with the paper industry. So closest to Aachen, between Aachen, Cologne and Düsseldorf, there is the model factory paper, very much for recycling and less energy use. It's already in the erection phase. And there will be also the digital nonwoven center, digital neutral clean, and both work very much together. We take nonwoven technologies in order to make waterless paper. We take paper technologies to use short fibers. And at the end, it's not all about textiles, it's also for infrastructure, furniture, technical uses, and whatever. There are already some examples of it. Disposables. If you take disposables, which is quite a significant portion of the average use per capita, then it's difficult really to do fiber recycling because it's highly biologically contaminated, and the biological waste in the diaper has also an entropy, so we can use it. So there is, for example, one company, a spin-off of Aachen University. They have made a very clever solution, a skid-mounted container-based solution for making recycling oil, which can be used decentralized, which can be used by, let's say, no-brainers, which don't have a chemical background. Very easy recycling disposables. Then there is, of course, other applications, technical home textiles. This is out of the Biotech Future. Thank you, Uday, for promoting our project. This is an umbrella project for all our green projects. And here we developed a turf which is fully biopolymer based and has also a recycling strategy. And this is not just made for paper, it's already in industry. There are, of course, composites. I know that very much in India we talk about carbon fiber at the moment pretty much. I would love to support the Indian fiber industry with all our knowledge about carbon fibers. There are many uses of it. We have also projects on hydrogen pressure vessels. And then the question is, of course, when you talk about carbon fiber, the mechanical properties and the need for it in many applications is given. But then the question is, it has a very negative carbon footprint in the beginning and at the end. We are working both of it. At the end, I don't want to go too much into detail. I showed you the recycling atelier in Augsburg. It's also very much working on composite recycling. Let's start with the beginning. Take the carbon fiber. There is a lot of literature around how to make a bio-based carbon fiber. Do you know where it started? It started 125 years ago in Aachen, where the viscose process was developed in order to make carbon fibers. But I would never ever recommend to use cellulose for carbon fiber. It's too fluffy, you have only a yield of 25+%. So cost-wise and structure-wise, you can do it, you have done it, but it's not the way to go. Also lignin is critical to handle to high-performance fibers. What I would recommend is to use other ways, for example, bio-based PAN, which is drop-in solution. You get the properties which are known, or bio-PE, which gives a cost-efficient, little lower quality carbon fiber. We have worked on that, we have brought this technology to lab scale, and now we are in discussion with industrial partner to scale it up to a pilot plant. Another option is to use natural fibers. So natural fibers especially are not substituting carbon fibers, but glass fibers, which is 10 times more than carbon fibers. And combining those natural fibers with natural-based thermoset or thermoplastic polymers is a good way to make the carbon footprint in the beginning very favorable. But still, recycling processes have to be developed, either bio-based or chemical-based.